So for dot plots, you're basically just going to make a dot that represents each of the data points. So so can I get a volunteer to read what exactly is a dot plot? Go ahead, Allison.
A dot plot is a data representative that uses a number line in x's dot or another symbol to show frequency. The dot plots are sometimes called line plots.
Awesome. So yeah, basically you just use a dot, or sometimes you'll see it using X's. Sometimes you'll even see it with little pictures, but whatever the dot or the object is that you're drawing, each one represents one number. So let's take a look at this example. 12 employees at a small company make the following annual salaries, and then we've got a list. All you're going to do is make a dot for each of those numbers. So I start with 25. I put a dot on the 25. Then I have 30. Then I have 35 two times. So I stack them up. Then I have 3 40s, 2 45s.
Miss, it's 335.
Oh, thank you. You're so right. Thank you. And then a 50 and a 60. And that's it. And there's my dot plot. It's pretty easy, right? Not too bad. And
I
so
think I did one of these.
you might have seen them. Yeah, you might have seen them in 6th grade. Now, why do you guys think that these are maybe useful for people to look at?
Because it just shows the amount.
Yeah.
Like,
What's very easy to see, like with your eyes?
the dots.
What about them?
How many
If there's three of those numbers.
Yeah, you can like very easily, rather than looking at that long list, which sometimes can be, like I missed the number when I was looking at the list. So sometimes the lists, especially if they're super, super long, they're just going to be hard to read and hard to like visualize. So this just puts it all in a picture, and it's very easy to see and very easy to like, you can tell which one is the most popular answer. You can tell if there's any outliers, things like that. So here's an example of what this would look like on a test. You're going to have to look at those 4 dot plots and figure out which one is correct. So take about 2 minutes to do that. See how fast you can get it done. Which dot plot represents the data? 30 seconds remaining. If you have an answer, you can put it in the chat. All right. All right, I'm seeing some answers, and it looks like the most popular answer is C. So let's take a look. Okay, if C is correct, why would A be incorrect? What's wrong with A?
There is no 22 in the line.
Good. Here's one example. There's no 22 in our data set. So that one's definitely out. What about B? What's wrong with it?
I was talking. I had my mic muted.
What's wrong with B?
There's 320.
It's got 3 20s and it's missing the number 19. There's a lot wrong with this one. What's wrong with D?
D has 228.
228. Yeah, we should only see 128. So that one's out. So you can always, with this type of problem, instead of sitting there and like matching every single dot to every single graph, you can figure out what's wrong with the rest of them and then go from there. Not too bad, right? Pretty simple so far. That's what I love about dot plots. But let's make it a little harder. You know, you got to make life a little interesting. So
Why?
we've been talking about these things called outliers kind of a little bit. I remember, I think Juan mentioned it on the first day. So can I have a volunteer to read the official definition of an outlier? Allison, go ahead.
An outlier is a value in the data set that is much greater or much less than most of the other values in the data set. Outliers are determined by using the first or third
Quartiles.
quartiles and IQR.
Awesome. All right, so on a dot plot, you can very easily see if there might be an outlier. So for example, where's the outlier in this one? Who stands out?
155.
Right, 150. I think it's just 150, yeah. But in any case, this one seems to be way, way, way larger than all the rest. But the thing is, sometimes in this example, I would say that's pretty obvious. But sometimes you might see one that maybe is over here or like over here. And it looks like it's a little bit out of the way, but it's kind of hard to tell whether or not it truly is an outlier because an outlier has a very specific definition. So here is how to officially make sure and identify whether or not you have an outlier. We have a little small formula to follow. So let's take a look. It says if the data value is an outlier, or a data value is an outlier if it is less than Q1 minus the IQ, less than Q1 minus 1.5 times the IQR, and I know it looks complicated, but we'll do it in a second, or greater than Q3 plus 1.5 times the IQR. So in order to figure out if something is an outlier, what are the two values I need to know?
Q1 and the IQR.
Q1 and the IQR for an outlier that's much lower. But here, since we have a value that's much greater, we need to know Q3 and the and the IQR. So let's go ahead and do that. We know how to do that by now. And it looks like these are already in order, aren't they? That's nice. Cool. So we need to find Q3 and then also calculate the IQR. So really we need to know Q1, Q3, all of the whole shebang. All right, here we go. What do I always have to find first though?
Q2.
Always Q2. Okay, so here we go. Q2. Nice.
40.
40. Easy. Do I include that 40 when I look for the Q1 and the Q3?
No.
Good. No, remember when your median is one of those numbers and not like in the middle of two numbers, when it is a number in the set, we ignore it once we split it apart to look for Q1 and Q3. So we ignore it, and now I'm looking for Q1.
35.
Right, it's right between these two. So that's my Q1. And what about Q3?
Between the middle of 45 and 50.
Yeah.
Go ahead and either, you can do it 45 plus 50 and then divide that by 2. What do you get?
47.5.
Awesome. Any final questions on how to calculate those values? Because at this point, we've done it enough. I expect you guys to know how to do it. Okay. So now I can do my IQR. IQR is going to be 47.5 minus 35. What do we get?
12.5.
12.5. Cool. All right. So now I can go ahead and figure out whether 150 is or is not a true outlier. So first I need to know Q3. Let's take a look. I'm just going to copy down what I highlighted up above. If it's an outlier, then it has to be 150 has to be greater than Q3 plus 1.5 times the IQR. So let's just fill in my blanks. 150 has to be greater than 47.5 plus 1.5 times 12.5. I just filled in Q3 as well as my IQR. And now let's do the math. Let's see if it works out. What is 1.5 times 12.5?
18.75.
18.75. And now we add 47.5 plus 18.75.
66.25.
66.25. Is 150 greater than 66.25?
Yes.
Yes, it is. Therefore, it is a true outlier. So 150 is an outlier. And like I said at the beginning, it was pretty obvious that that one was an outlier because when it's that far away, it's like, okay, yeah, that's an outlier. Cool. But sometimes that outlier might be a little bit closer and it's hard to tell if it really is an outlier. So we always need to check it out first in order to tell. Do I have any questions on how I plugged in those values or anything like that?
Wait, so it's an outlier because it's greater than 66.25?
Yeah, exactly.
Oh, I was a little confused because I thought we were like that 55 equal, like, just.
Well, what it's basically saying is that 66.25, let me see where that is. That is like somewhere around here on my number line, right? What this is basically saying is that any value greater than that, anything in this direction is an outlier. Okay? So that's kind of like the limit. Anything greater than that is a true outlier. And same thing goes on the other side, but we haven't calculated that yet. We're going to do that in the next slide. But if you do Q1 minus 1.5 times the IQR, matter of fact, we might as well do it. We have the values. So we know that if X is less than Q1 minus 1.5 times the IQR, that'll also be an outlier, but on the other side. Okay, so what is Q1?
35.
Q1 was 35, so 35 minus 1.5 times 12.5. And guys, the title, I'm seeing it in the chat. I'll write it down at the top. Dot plots and histograms. Okay, so finishing this up, we already know 1.5 times 12.5 gave us 18.75. So what is 35 minus 18.75?
16.25.
16.25? So anything less than that would also be an outlier. So there's a limit on this half, probably somewhere over here. Anything less than that value would also be an outlier. And that's what that's how we like the official definition of an outlier. And that's how we always, those two little like inequalities, we use those to figure out if our number is an outlier or is not an outlier. Does that make a little bit more sense? Hopefully. We'll do another example, a couple more examples. So let's try this one. So first things first, I need to make my dot plot. So baseball pitchers on a major league team throw at the following speeds in miles per hour. And then we have a few examples. So let's go ahead and fill this in. And just like in the previous problem we saw, it might be, they might use letter X's. You might see dots like this one. Sometimes they even use cute little pictures, like this could be like little baseballs, you know, like that, and it, you know, whatever. But I'll use just circles for mine. So I've got 72, 84, 89, and this is all out of order, so I'm gonna have to put it in order soon. 81, 93, 100, 90, 88, 80, 84 again, and 87.
You put 93 in the wrong spot.
Did I? Oh yeah, thanks. There we go. Okay, so here's my dot plot. It's a little bit, I don't know, how would you describe this one? How would you guys describe it? Would you guys say that this looks very even or a little bit uneven?
I would say uneven.
A little uneven.
Yeah, a little uneven, right? It's not very clear, like maybe there's outliers. Which numbers might be outliers?
The
100?
the dot in the middle of the 70 and the 75.
Yeah, what's that? 72 and 100. So it's kind of hard to tell, right? This is what I was saying before. Sometimes it's very obvious, like in this problem, that was pretty obvious. But sometimes it's a little bit hard to tell. So this is where those little inequalities really, really help us out. So I'm gonna rewrite them. And this is something that I would definitely try to memorize. It's not too hard to memorize though. So if x is less than q1 minus 1.5 times the IQR, we would get an outlier in that direction, as well as the opposite direction. So if x is greater than q3 minus 1 point, or plus 1.5 times the IQR. So we're gonna have to test out both because we have a number on the lower end and we have a number on the upper end. So we're gonna have to test both out. But before I do that, what do I have to find?
Q1 and Q3 and IQR.
All right, so I'm gonna go ahead and put these numbers in order so that we can do that. See if I can fit it all. I don't know if I will. Maybe I'll put it down here for now. Okay. 72, 80, 81. And this is where now I'm kind of just looking at my dot plot, and it's a little easier just by looking at the dot plot because that's already in order. 87, 88, 89, 90, 93, and 100. Okay, you guys go ahead, take about 3 minutes to find Q2, so find the median, then Q1, then Q3, then the IQR. Nice, guys. I'm seeing lots of correct answers. Okay, if you're still working, I'll give you about 1 more minute, but if you already got all of those things, Q1, Q3, and the IQR, use those inequalities. See if you can figure out whether 72 and 100 are outliers. Okay. All right, so here we go. So let's take a look. Who can tell me what is the median? What's my Q2?
87.
87. So this number is right in the middle. That makes it my Q2. What about my Q1?
81.
81, yeah. That 81 is right in the middle. That's my Q1. What about my Q3?
90.
90. Any questions on Q1, Q2, or Q3? Okay, so I'm going to write these down. Q1 is 81. Q3 is 90. And then how do I get my IQR?
Subtracting.
Subtract them.
11.
Good. So 90 minus 81 gives me,
11.
careful, not 11. It's
9.
9. Yeah. 90
Wait.
minus 81.
Oh.
It's okay. Okay, now we have everything we need. I'm going to erase this because we don't need it. We have what we need. We have Q1, Q3, and my IQR. So let me bring these guys back up. Here we go. We're trying to figure out if 72, I'll start with 72. Trying to figure out if 72 is an outlier. So I'm going to see if it is less than Q1, which is 81, minus 1.5 times 9, my IQR. So it's 1.5 times 9.
13.
13.5. And then what is 81 minus 13.5?
67.5.
Yeah.
Good. 67.5. Is 72 less than 67.5?
No.
It is
It's
not.
greater.
It's greater than that. So 72 is not an outlier.
Can you try it the other way?
Which one? It's another 100?
The x greater than.
Yeah, so now so for the other side, we're gonna check to see if 100 is an outlier because we already checked 72. Now we can check 100. So I plug everything in, Q3, that's
Yeah, you're
90.
gonna do homework. I'm gonna see. Yeah.
And then 1.5 times 9, which we already know 1.5 times 9, so that's nice. So all we need to do is what is 90 plus 13.5?
103.5.
103.5. Is 100 greater than 103.5?
No.
No.
Nope. So 100 is not an outlier either. They both could have been, they both kind of looked, and 100 was pretty close to being an outlier, but they both fit within the boundaries that we set, okay? So both of them are not an outlier. Questions? Questions, anything at all? Okay. One last little thing is, remember how I said the word skewed before? So there are two ways for data to be skewed. Either they are skewed to the left or they are skewed to the right. And basically it all comes down to the shape that the data makes. Okay, so let's take a look. Here's 3 examples. What I always like to picture is a hill. So picture a little hill. If I were to draw a hill just kind of on top of my data, the one in the middle is very symmetric, right? Like you can very easily just go up the hill and then back down the hill. Now it might not be exactly perfect like this one, but we'll see some examples where it's very, very nice and even. And that would be a symmetric graph, but that also has a different name and a more important, a more common name that you will see. So let me write that down. So this would be normal. It's called a normal distribution. And what that basically says is that, so the word distribution is basically saying that all of the data values are distributed very evenly on both sides, okay? That's why it's normal. It's very symmetrical. Everything is nice and even. But then we've got these 2 other examples. We've got skewed to the left and skewed to the right. And basically what that means is that if your data is skewed to the left, that means that there's some outliers on the left side. That's why it's called skewed to the left. That always kind of confuses me, at least a little bit, because to me, skewed to the left, it kind of looks more to the right, if that makes sense. Like most of the data is on the right-hand side, but that's what they're called. So I want you guys to just look at it the way it is right now and remember that skewed to the left means it's got some outliers on the left, and skew to the right means I've got some outliers on the right. Okay, this can be a very easy question on a test to answer, okay? It's all about just looking at the shape of the graph and then determining whether it's skewed or not. Do I have any questions on that?
Will this be on a test?
Yeah, this is a very fair question that could come up, yeah. And I think I have some examples. Yes, I do have some examples, okay? So let's practice. So for each example, describe whether the dot plot is normal, skewed left, or skewed right. Let's do that first, and then after that, we'll determine the mean and the median. We'll do that later. So starting with example 1. What do we think? Team A versus Team B. Any of them normal versus skewed?
Team A, no.
It's kind of normal.
Yeah, Team A is normal. And remember what I said, it might not be perfect, but this is a very even hill, right? You go up, you go down. That's normal. What about Team B?
It's not. It's like more skewed to the right.
To the left?
To the left. Yeah. Remember.
Oh, wait, I don't know my left hand.
Yeah, I know. It always messes me up too. So just keep in mind, skewed to the left matches the one I have over here. So this is skewed left. What about example 2?
Normal?
Pretty normal.
Yeah. So which one's normal, A or B?
A.
Yeah.
A.
It's a very tall hill, sure. It's a very tall hill, but it's still even on both sides. So that's also normal. And what about the grocery store B?
Skewed
It's
to
skewed
the right.
Skewed to the right, yeah. So kind of like, yeah, skewed to the right. Okay, good. Not too hard to notice that like visually. But now let's see what that means about the mean and the median. So luckily in dot plots, and especially like these, they're very small, not too many numbers in them. It's not too hard to calculate the mean. Because all you got to do, so let's take a look at team A, for example. If I were to list all these out, I would just go in order. I have 2 3s. That looks like 3.5, right? So
Mhm.
3,
Yeah,
3.5, 3.5, 3.5. And I could keep going, but I can also just plug that directly into my calculator. So if you're calculating the mean, remember, we're going to add all of those values up and then divide by the total number of values. So I would go in my calculator, I would go, okay, 3 plus 3 plus 3.5 plus 3.5, and I keep going, plus 3.5. So do it with me. Then it looks like there's 4 4s, so plus 4 plus 4 plus 4 plus 4. There's 4 4.5, so keep it going, see what you get.
I messed up.
If you
Me
messed
too,
up,
I
start
deleted
again.
mine. Like
Okay,
I
start
deleted all of
again.
it.
Start again, and then let's see. I got 76.5, but I could be wrong, so tell me whether you get the same answer or not.
I got 60,
76.5.
76.
So we got the same answer, 76.5?
Yeah.
Cool. Okay, and then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 x's. So we're going to divide that by 18. So what's my mean?
4.25.
4.25. Good. That's the mean. Now for the median, remember, usually with the median, I would have a long list of numbers and I would cross them off from the outside, right? Well, I don't want to write that whole...
The median is 4.3.
So that's why I don't want to cross off all those numbers, and that seems like it's going to take a lot of time to write them all down, but I can use my...
Because the two middles are 4 and 4.5, so it's 4.3.
Right, so basically, Allison, what she's seeing is that there's 2 over here, 2 over there. There's 3 over here, 3 over there. And then I'm basically down to, if I kind of cross things off here, it's got to be 4 and 4.5. Those are my 2 middle values, 4 and 4.5. So we do what we usually do, 4 plus 4.5, and then divide that by 2. What do you get?
4.3.
Try it again. 4 plus 4.5
8.5.
divided by 2.
4.1.
4.1? What's 8.5
Wait,
divided by
how'd I
2?
get that?
25.
You should get
4.5.
4.25. Yeah. So what
Oh yeah,
happens?
425.
What happens? My mean and my median are the same. They're exactly the same.
Wait, may you repeat how you got the median again?
Sure. So remember that the median is the middle value. It's whatever number is right smack in the middle, right? When you put them all in order. So on this type of graph, rather than writing out all those numbers and writing it, and it's going to be a very long list of numbers, rather than doing all that, we can just kind of cross things off on the graph. So I'm crossing off 2 to the left, 2 to the right, 3 on the left, 3 on the right. And then I'm down to 4 and 4. So I can cross off 3 on the left and 3 on the right.
I got
And now I'm between those two.
Right. Before I got 4.3 because since 4.5 and 4.3 in the middle, it says 4.3.
Well, 4.3 is close to the middle,
4.
but 4.25 is the middle between 4 and 4.5.
So we add 4 plus 4.5 and divide it by 2?
Exactly.
Yeah.
Exactly. Okay, so what do you guys notice? Look, the mean and the median, they're exactly the same. And that's exactly what makes something normal. So that's kind of like the actual definition of normal. If the mean and the median are pretty much the same, sometimes it might be a little bit like a tiny amount smaller or bigger, but if they're pretty much the same, you've got a normal distribution. So let's see what happens when something is skewed. Let's see what changes. So same thing, I want you guys to try it on your own. Start by calculating the mean. So we're going to add all those numbers. Same thing, 3 plus 3.5 plus 3.5. Keep it going.
$86.5.
Good, I got the same thing. See if you should also get 86.5.
I messed up at 5.5.
Oh no.
I always add an extra. Like I always add extra.
Yeah, you
Yeah.
have to be very careful with these. 86.5 divided by, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, also 18. What do we get?
4.80.
4.80.
That was quick.
Okay, great. Now let's see about the median. So this one's a little bit harder because it's a little bit more obviously skewed, but let's take a look. So I cross off 1 on the left, 1 on the right, 2 on the left, 2 on the right,
It's 4.5.
2 on the left, 2 on the right,
Oh wait, no.
2 on the left, 2 on the right, 1 on the left, 1 on the right, and now my middle values are both 5, which means my median
Is 5?
is 5, yeah.
Wait, what?
Okay, so here is what I've got.
Wait, what? Wait, you cross by how many like little points there are?
Yeah, so I can do it. Okay, let me do it again. So I'm going to just cross 1 on the right, 1 on the left, back and forth. So
Because I
cross
thought it
one.
would be 4.5 because.
Look, watch
I
carefully.
don't know.
I crossed off 1, cross off 1, 1 and 1, 1 and 1, 1 and 1, 1. Keep it going.
Oh, so you just cross out everything by 1.
Yep. What am I left with?
2.
Oh, I see.
2 5s. So that's my 2 middle values. That means my median is 5. Okay. Now, which one is bigger, the mean or the median?
Median.
Median, right? The median is at 5, and the mean is a little bit below that, 4.8. That's another reason they call it skewed to the left, because the mean is on the left of the median. Skewed to the left. The mean
So
is
anything is
less.
greater. If anything is greater, that means we had the mean wrong.
So what that means, well, what do you mean? Say that, explain that one more time.
You said the mean would always be on the left. So if the mean is on the right, if it's skewed to the left, that means we had the mean wrong.
Or maybe you thought it was the wrong skew.
Oh, okay.
So you gotta just be careful. So on grocery store B, what do we expect? Where will the mean be? On the left or on the right of the
Right.
median? Should be on the right, right? So go ahead. These are kind of bigger numbers. There is a lot of numbers here. It might take a minute, but see if this makes sense. Let's try the mean and then the median. Luckily, there's like 3 zeros, so you don't have to add those. And by the way, it goes 0, 50, 100, 150, 200, 250.
Can we like times it? Because
You can. That's what I'm doing.
I got 3,200.
Okay, I'm almost there. Okay, me too. I got 3,200. 3,200 divided by 1, 2, 3, 4, 5, 6, 7, 8, 16, 20, 1, 2, 3, 4, 5, 6,
29.
26, 29, yeah. I got 110.3.
4. Oh, okay. We don't have to add like the.
Yeah, no, I'm just kind of keeping it simple.
All right.
All right, and now here we go. Just crossing one by one.
I almost had it, but I just lost track.
Okay, all of my middle numbers are 100s. My very middle is 100, so my median is 100. And what does that mean? That means that my mean is to the left or right?
Right?
To the right, yeah. The median is 100. The mean was 110. It's a little hard, sorry, it's a little bit messy. But basically the mean is to the right, which is why we call this skewed right. Kind of a lot of work sometimes, but this is, again, kind of like with the outliers. Remember, sometimes it's very obvious, like this one. Sometimes you got to put in the extra work to know for sure. And that's the same thing with these. Sometimes it's very obvious, like these graphs here, pretty obvious, you don't have to do the work. But sometimes, like maybe in grocery store B, it's not so obvious and you might want to do the extra work just to check. All right, so do I have any questions on how I calculated that, how I figured out whether it was normal or skewed?
I have a question for Team A.
Sure.
When once you got to the final like 4 and I believe 4.5,
Yeah.
you like did you not mark the last X's?
Yeah, so you mean when I was like crossing these off?
Mm-hmm.
So when you cross these off, if I keep going one by one, what happens? I'm down to 2. One of them is a 4 and the other one's a 4.5. Right? So
That's
then we do what we normally do. We add them up and divide by 2.
Oh, I was a little confused because I thought like
For grocery store A is 3,250.
Oh, you were going for grocery store A? I kind of skipped it because that one's very similar to Team A, where it is very, very obvious that it's normal.
Yeah.
But if you want to put in the work, go for it. Okay.
Yeah,
Now,
and the median is 150.
so you got the same answer?
Mm-hmm.
Yeah, that's good. So yes, normal versus skewed. So that is all for dot plots. Do I have any final questions on dot plots? Okay.
Wait, it's
Yeah.
not 150, it's 125.
Yeah, you're right, because it would be between 100 and 150. Okay. All right, so now we're going to do histograms, which are actually very similar. That's why I put them in the same PowerPoint. They're very related to each other. Can I have a volunteer read what a histogram is?
I'll read it.
Go ahead, Allison.
A histogram is a bar graph that uses the display of frequency of data divided into equal
Intervals.
intervals. The bar must be equal within the and should touch but not overlap. The heights of the bar indicate the frequency of data values within each interval.
Perfect, thank you. All right, so we have this example here. It looks like they measured what the score of different students was on a math test. So this is how we read a frequency or a histogram. First of all, take a look at the x-axis. The x-axis is the test scores. And basically, we treat those test scores like buckets. Like it's measuring how many students had a test score between 60 and 69, how many students had a test score between 70 and 79, 80 and 89, 90 and 99. And notice that each of those intervals is even, okay? Each interval is 10 values, 60, 61, 62, 63, 64, 65, 66, 7, 8, 9, 10 values. So each one, it's basically dividing it very evenly and then measuring how many students fit into each bucket. So how many students had scores between 60 and 69?
2.5.
3.
Oh,
3.
3.
Yeah, 3, good. And what I always do with histograms is I like to label them right away if I see one, it's easier to like see it that way. So I always label it. What about 70 to 79?
9.
9. What about 80 to 89?
12.
And the last one?
7.
7. Exactly. So that's the basic histogram. And just like dot plots, histograms, you can see the shape of it and you can see whether or not it's normal or skewed. So what I'm going to do first is let's actually make one. And I think let me see which one I want to do. I'll do this one. Okay, so creating a histogram. The first step of creating a histogram is figuring out like the range of numbers that you want to measure. So they kind of started it for us in this example, but I look at my list and I notice that all the numbers in my list are between 68 and 70 what? What's the highest value?
$77.
There's 77. I see one that's higher than that, 78.
Oh.
That's as high as it goes, right? 78. So I got to go from 68 to 78, and I have to split everything evenly. So in this case, they want us to use an interval of 3. So each one is going to be 3 values. So for example, the first value would be from 68, 69, 70, so up to 70. Then 71, 72, 73, 74, 75, 76, 77, 78, 79. So it's going to go a little above 78, but that's okay.
So you're adding by 3 every time?
Yes, yeah. All the intervals are in groups of 3. So it's dividing it into groups of 3. And then what you do is you go through your list and you're going to see how many of those numbers fall between 68 and 70. So I've got 68, 69, I have a 70. Does anyone notice anything else? I think that's it. So there's 3 values 3 of those fall between 68 and 70. How many values fall between 71 and 73, including 71 and 73?
4.
Okay, so I've got 1, 2, 3, and 4. Yeah. What about between 74 and 76?
7.
Wow, okay. So yeah, we got 1, 2, 3, 4, 5, 6, 7. Good. And then the last 2 are in that last interval. All right, so that's all we do first. We just count, okay, how many fall into this bucket, how many fall into that bucket, and just tally it up. Any questions on that part so far? Okay, cool. And now I'm just gonna make my frequency table. So first I start with just drawing my X and Y axis. The Y axis is always just your frequency. Now frequency is always gonna be like, look at what's the biggest number for frequency? 7. So what would be a good maximum to put on my table, on my graph?
8.
Yeah. 8 is good because now I can I can split it very evenly.
By 4s.
Yeah.
I mean,
by
because
2s, yeah. And then on my x-axis is the intervals. And just remember that those have to be split perfectly evenly. And since I have 4 of them, I'm just going to try my best to divide this into 4 even looking sections. That's not bad right there. And I'm going to label them. So 60 to 7, or 68 to 70, 71 to 73, 74 to 76, and 77 to 79. And now here's the fun part. I can make my bars. And I always like to make them colorful. So starting with my first one, that's going to go up to 3. Make that nice and even. And you can fill it in. Should pick a thicker brush. Okay. My second bar has to go up to 4. Let me make this a little thicker so I can fill it in nicely. I'll make that a little bit nicer. Okay. And you would just keep going like this. You just fill it all in to the correct frequency and make it pretty. So as I'm continuing and finishing this, do I have any questions so far?
on the test, it won't ask us to shade it in, right? Because, you know, we're on computer and that pretty.
On a test, and some of you guys might have done the extra credit Khan Academy last week that I had you do this. It's a lot easier on a test because if you have to make your own, they make it very, very technologically easy to do.
Okay.
You would basically already have everything for you, and all you have to do is like drag the bar to be a little higher or a little lower depending on where it needs to be. But if you're doing it by hand, then yeah, you would have to just be diligent to make sure it looks nice. Oh wait, this should be 2. So that's basically it. There's my bar graph. So or my histogram. Any questions? It's not the most perfect because I made a little bit of, it's a little tilted, but any questions? Okay. So let's see, it's 10:19. I kind of want to move on because again, on a test, you won't have to make it like the way that I just did it. It would be a lot easier. So rather than having us do another example, I'd rather go on to the ones where we get to analyze it.
Wait, what happened to the third question?
Oh, use an interval width of 3 and start the first interval. So the first interval started at 68. That's all that was.
Oh, okay. Because what if that happens in the test? We'd be like, oh.
Yeah, make sure you fill in all your answers. Yeah. Okay. So skipping that one. Okay, now we can analyze some of them. So the histograms shown display the number of cans of food donated by students in the freshman class and the sophomore class at the school. Estimate the mean for each class and determine which one is greater. So here's the thing with histograms, unlike dot plots, and let me just show one more time a dot plot. Okay, on a dot plot, remember we were able to calculate the mean because each dot represents one of the data values. So you know there's, okay, 3, 3, 3.5, 3.5, 3.5, 4, 4, 4. You know, we were plugging all of that into our calculators like crazy. On a histogram, we don't know. We know that there's, for example, in the freshman class, I know that 22 people were between 55 and 60, but I don't know if those 22 people had 55, 56, 57. We don't know. We only know that they're in that bucket. So it's a little bit harder to know for sure what the mean and the median and all of those things would be. But there's a trick that we can do to figure it out. So here's what we do. Let me just double check our time. Yeah, we've got time. All right. Here's what we do. First thing is we figure out the total. So in order to figure out the total number of people, let's start with the freshman class. We would have to figure out how many are in each bucket. So like I said, the first bucket, I have 22 and 22 here as well. What about the next bucket?
The next bucket is 25.
25.
The next bucket is 27 or higher. You don't know, maybe.
It's 27. They wouldn't, on a histogram, if that's the top value, that's where it stops. It doesn't go higher than that.
Okay.
Next one
is 24.
24.
The next is 22 again.
22 again. And finally,
21.
21. Okay. So first we find all our totals. Then what we're going to do, and this is where it gets a little bit complicated, so I want you guys to just keep track, copy things down the way I'm copying them down once I start writing it down. Next thing I need to know is what is the middle of each bucket? So if the first one is between 50 and 60, what is the middle of that? Between 55 and 60.
We need to find the median of
57.5.
Yeah, for every single bucket. So we already know we can add those two numbers and divide by 2. So 50 plus
Isn't it
60.
57.5?
Yeah, that's going to be 57.5. What about between 60 and 65?
60.25.
Let me write this down here. 60 what?
62.25.
62.25.
Mm.
0.5, I mean. Oh, I see what you said. 62.5.
I tried doing that last time and you said it was 25.
What about between, because that was between something and something 0.5. Okay. What about between 65 and 70?
67.5.
67.5.
70 and 75?
72.5.
75 and 80?
77.5. It's the same thing. It's just
Yeah, there's a pattern. 82.5.
Is it adding by 5? I mean, by like 15 something? 10.5?
Yeah,
wait. Subtract 57.5.
because it's always like in between, since each interval has 5, halfway would be plus 5.
It's by numbers. Wait, what am I?
Okay. Now I've got everything I need. I have my totals and I have my middles, okay? So watch carefully. Here's what we're going to do. We're going to multiply each of those. So we're going to do 57.5, the first middle value, times its total, so times 22. And we're going to do that for every single one of those bars. So start working on that. I'll write it down. Let me see if I can write it. Let me write it a little bit smaller so I don't run out of room. So again, 57.5 times 22. What do I get?
1,260.
Say that again.
1,265.
1265. And then I go and I keep going all the way down my list. So now I'm doing 62.5 times 22. And then I'm just going to start writing these down and you guys start calculating it in your calculators.
We're multiplying all of them by 22?
No, multiply it by whatever value.
Oh, so
has.
like 72.5 would be multiplied by 27?
Yeah.
Oh.
Okay. I'm going to work on this, but starting from the end. So we'll meet in the middle.
I started from the end, but it was before you wrote 82.5.
Oh.
A 1,860 for
Okay. Who's got the second value? So going down.
5.
Say that again. Oh yeah, for 62.5.
1,375.
Okay. What about the next one?
1,687.5.
Okay. And the last one?
1,957.5.
Awesome.
why is he so quick at math?
Yeah, Ajira's sitting there on her calculator like, you know that meme of the cat going on the laptop like this?
He's really fast at it.
Okay, so now, okay, I've got all these values. Here's the last step. I need to know my grand total. So let's add up all of these sections, all of those totals. So 22 plus 22 plus 25 plus 27 plus 24 plus 22 plus 21. What do I get? 163. So what I'm going to do is I'm going to take all of these answers that I got, all of those, add them up, and then divide by 163. So we're kind of taking the
Yeah, that's a lot of
mean.
work.
We're going to take the mean of all of those numbers. So let's go ahead. I know it's a lot. This is a lot of work, guys. This is like not, it's not hard, but it's just super, super long. So that's why I don't want you guys to have to do it a bunch of times.
Wait, what are we doing?
So add up all of these answers that we got from the previous step, all of those, add them up, and then we'll divide it by 163. Oh, I already messed up.
Then we divide it.
Wait till you get your total so that we can compare and make sure we have the same total.
Divided by what
I
again?
got the total.
All right, what did you guys get for your total?
11,797.5.
I got 11,797.5.
Good.
So we got the same.
We match. Okay, so we get 11,797.5. We're going to divide that by 163. Let me know what you get.
72.3.
72.3773.
So I'm going to round that to 72.4. That is our estimated mean. Whew, it took a long time, but we got there. And notice 72.4 is kind of like right smack in the middle, isn't it? 72.4 will be somewhere like right below 72.5.
It's right in the middle.
So it's like pretty much right in the middle of all of the values. And that's because this graph, what would you guys say? Is it normal or is it skewed?
It's normal.
It's pretty normal,
Yeah.
yeah. Maybe
Yeah.
there's a little bit more, I don't know, it's a little uneven, but for the most part, that thing goes up and it goes down very evenly.
And
So
also,
You can hear my birds chirping.
and what were you saying, Ijara?
the mean is in the middle and not on like the left or the right.
Right. Everything's kind of right in the middle, exactly. So that definitely is probably the most time-consuming thing you would ever have to do on a test in your life. But chances are you probably won't really see a question like this. They're not going to make you sit there and do this 1,000,000 times. So you might see it once. You might see like one question like this on a test, but at the end of the day, when you know it's already normal, it's not that hard. Like if the question is saying, is this normal? You can pretty much estimate the mean by looking at what's right in the middle. So we can look at just what was right in the middle, and that would have given us kind of the same answer anyways.
Hopefully that question is on the calculator part of the
Oh, it would definitely be on the calculator part of the test for sure. So what I want to do with the sophomore class is rather than do all that work, first of all, does it look pretty normal to us?
No.
To you guys?
It looks skewed
Go to the left or the right.
No,
Okay, it might be a little bit skewed, but remember, skewed is like when something is skewed, it's going to be really
it's kind of
skewed.
normal, but
Yeah, when something is skewed, it's going to be really, really skewed. So remember what I said at the beginning. Normal in real world situations is never going to be perfect. It's never going to be perfect. But this one's pretty close. It goes up and it comes back down, and the hill might be a little bit skewed, but not that much. I would say this is closer to normal than it is to being skewed. And since I would say this is close to normal, what would you estimate the mean to be? So where's the middle of this?
80.
80, yeah. That's the middle. So the mean has to be somewhere around, and those little squiggly lines are like the mean is about 80. Might not be equal to 80, but it's going to be somewhere around there. So if you're on a test and you're pressed for time, rather than go through all of this work that we did, pick the number. If your answer choices are something like this, let's see. Which of those is it going to probably be?
79.5.
Exactly. So that's the quick trick to getting an answer without having to put in all of that work.
Oh, so it will be like, oh, the mean of this equation is blah blah blah, and then it gives you your answers, like, is it this or is it this?
Yeah. And you're just going to pick if the graph is normal. If it was skewed, that's a different story. If it was skewed, you might have to put in all that work. But if the graph is normal, it's going to be somewhere in the middle. So we just figure out which one's in the middle. Okay. All right. And this is just my last slide. This is just a reminder. Like I was saying, when something is skewed, it's skewed. Okay, so for example, the one on the left, Would this be skewed to the left or skewed to the right?
Skew to the left.
Skewed to the left. The one in the middle might not be perfect. Might not be perfect, but it's more normal than not.
Yeah.
So this would be normal. And then this one,
Skew to the right.
skewed to the right. And that is it, guys. So at this time, we are done a little bit early, and that's totally fine by me. I'm happy to end things a little early. But if let me just stop my